The search for life on Earth depends largely on the ratio of carbon dioxide to other gases in the planet's atmosphere and the various biological markers that increase life. Imagine how abundant life is on planets, worlds 2 to 6 times the size of Earth, surrounded by vast oceans. These dwarf planets represent a new class of planets that have intrigued scientists, known as subneptunian planets. Hien's blue world was brought to attention when the James Webb Space Telescope discovered abundant water and hydrogen gas in K2-18b. This discovery reveals the nature of the vast ocean and possible life. K2-18b, a planet 6 to 8 times the mass of Earth, orbits the cool dwarf star K2-18 in the habitable zone, about 120 light-years from Earth. It is between the size of Earth and Neptune, and the presence of methane and carbon dioxide, and the absence of ammonia, supports the theory that K2-18b has a blue ocean beneath its hydrogen layer. The James Webb Space Telescope also discovered another interesting fact, a molecule called dimethyl sulfide DMS. On land, DMS is only produced by life, mainly phytoplankton in marine environments. Future observations of the site will confirm these findings and provide significant evidence of biological life on K2-18b. This life varies from simple forms such as plankton, algae, and microbes to more complex organisms such as fish or aquatic mammals. Life on other planets may be larger than we currently think. Even on a planet completely covered in water, higher life forms may have adapted to living in watery environments. The presence or absence of land masses in K2-18b is uncertain and difficult to determine externally. James Webb's ability to detect artificial light emissions similar to those coming from cities on distant planets. This potential represents a major advance in our search for extraterrestrial life. K2-18b was not first discovered by James Webb. However, the Hubble Space Telescope provided the first look at its atmospheric properties. Promising information from Hubble led scientists to re-evaluate their research with a new telescope, which led to important revelations about K2-18b. These analyses are interesting and may represent our first real-world indicators in space. This discovery is very important in the nearly 100-year search for life in the solar system, which has yet to yield any definitive results. No life has been found in our solar system, and the distant icy moons orbiting Jupiter and Saturn are considered candidates. According to researchers, these exoplanets can be very large worlds and cradles for diverse life. Land life began in water, and later land masses and mammals appeared. If Earth had remained a water planet, intelligent life forms compatible with water organisms might have developed. Historically, the search for extraterrestrial life has focused on exoplanets, especially small rocky planets. However, Hien's worlds are considered the most important worlds in the world. Although not all scientists are convinced, the oceans of these planets may be too warm to be habitable or floatable. In these situations, Hien's worlds resemble giant bathtubs. Yet the existence of life in the hot and toxic hot springs of Yellowstone Park demonstrates the adaptability of life even under harsh conditions. The discovery of K2-18b raises a powerful question. Can we determine if this planet is habitable? If intelligent life is found in the area, the need for contact will arise. K2-18b, located about 124 months from Earth, poses a major challenge to our current solar capabilities. It takes many years for our probes to reach places millions or billions of kilometers away. A planet 124 light-years away, although a planet only 4 light-years away, is beyond our reach with any probes or spacecraft. Voyager, launched in the 1970s, will take thousands of years to reach nearby star systems. Establishing relationships with species in space requires a creative approach. The idea of discovering Earth-like planets in our nearest star system, Proxima Centauri, inspired Yuri Milner to design nanoships. These small probes, equipped with cameras, are expected to travel billions of kilometers in a few years to take pictures of potentially habitable planets. If a planet is discovered in space, scientists will develop all new strategies. These ambitious goals fuel our spirit of research and innovation. In the future, and with warp drive technology that makes it possible to travel to worlds by warping space, traveling to worlds like K2-18b is no longer a challenge. However, our spacecraft operate within the limitations of Newtonian physics and rely on propulsion through propellants and fuel. Even if a spacecraft were built that could travel at 10% the speed of the Moon, a trip to K2-18b would take 1,240 years. A radio signal traveling at the speed of light takes 124 years to cover the distance between Earth and this distant planet, and the answer arrives 124 years later. The discovery of exoplanets, such as the case of K2-18b, shows that the search for extraterrestrial life is an important role in the universe. As technology continues to develop, we have become much better at finding and analyzing distant worlds. One of the most interesting objects in recent years is the exoplanet K2-18b, which is 120 light-years from Earth. The planet has become a hot spot for scientists because of its unique features that indicate habitability and possible life. This comprehensive discovery looks at the scientific background of K2-18b, the technologies involved in its study, and the broader implications for our understanding of the universe beyond Earth. The significance of K2-18b lies in the location of its host star, a cool dwarf star called K2-18. This region is important because it is the area around the star where conditions are just right for liquid water, a key ingredient for life as we know it. K2-18b is between Earth and Neptune in size, making it an excellent candidate for studying atmospheric and geological features that indicate habitability. One of the most interesting features of the K2-18b is its gas structure. Observations from the James Webb Space Telescope, JWST, revealed hydrogen gas and traces of water vapor. Seeing water vapor is important because it indicates a large amount of water, possibly a large ocean. The presence of methane and carbon dioxide supports the hypothesis that K2-18b may have been a closed product, possibly keeping the temperature constant for liquid water. Methane is very interesting because on Earth it is produced by most biological processes. Its presence, along with other gases, helps create a trace of the gas chemistry of K2-18b that can provide clues to possible biological activity. The absence of ammonia, a common toxic compound, is also popular, as it supports the idea that it is more environmentally friendly. The discovery of K2-18b was made possible by advances in telescopes and observational technology. The James Webb Space Telescope has provided unprecedented information for observing distant exoplanets. Its ability to detect and analyze light from distant worlds has revolutionized our understanding of planetary atmospheres. JWST is the most advanced space telescope ever built, marking a leap forward from its predecessors such as the Hubble Space Telescope. Equipped with powerful infrared instruments, JWST can probe through the thick clouds of gas and dust that surround exoplanets and their host stars. This ability allows scientists to analyze the composition of exoplanet atmospheres in unprecedented detail. The telescope's ability to detect dimethyl sulfide (DMS) is remarkable. On land, DMS is a molecule produced by living organisms, mainly phytoplankton, in marine environments. The presence of DMS in the atmosphere of K2-18b is a strong indicator of biological processes, suggesting the existence of life on this distant planet. The search for extraterrestrial life takes many forms, from studying planetary winds to searching for clues from ancient civilizations. The discovery of potentially habitable exoplanets like K2-18b is an important step in this search. Biosignals, chemical or molecular indicators of life, play an important role in exoplanet research. Identifying biological signals in the atmosphere of a planet can reveal biological activity. The presence of gases such as methane and oxygen, especially when combined, is a strong indicator of life. On Earth, these gases are created by living organisms, and their observations on other planets reveal similar processes. The Drake equation is a tool used to calculate the frequency of interplanetary energy in the Milky Way. Various factors are considered, including the rate of star formation, the ratio of these stars to planets, and the number of planets that can support life. Discovering potentially habitable exoplanets like K2-18b adds valuable data to the equation, helping to refine estimates and guide future searches. Despite the exciting discoveries, studying exoplanets like K2-18b poses many challenges. The long distances and limitations of current technology make it difficult to gather accurate evidence of survival. K2-18b is 120 light-years from Earth, a distance that presents significant challenges for space travel with current technology. It takes years for spacecraft to reach nearby star systems and travel to a planet 120 light-years away.